Opportunistic Tangible User Interface, or Opportunistic TUI, allows end users to control digital functions of smart objects and augmented reality applications by interacting with physical objects with haptic feedback. Prior researchers have developed multiple TUI authoring systems that enable users to customize the mapping between the physical input and digital output functions to fulfill diverse user needs. Users need to find physical objects that hold the affordance that is highly similar to the desired digital function, such as pulling the spray bottle handle as a button and repurposing the bottle-shaped physical object as an AR wine bottle. Edges on a physical object, on the other hand, have higher generalizability to be leveraged in opportunistic TUIs because edges exist ubiquitously on everyday objects and can provide accurate haptic feedback for assorted TUI inputs, such as buttons, sliders, and knobs. We propose Ubi Edge, an authoring system that empowers end users to author edge-based opportunistic TUIs in augmented reality. We build a customized, integrated head-mounted device by mounting a LiDAR camera onto a HoloLens 2 AR headset and design a vision-based processing workflow so that Ubi Edge can accurately detect the edges on everyday objects and pervasively track the user interactions with the physical edges. Now we will demonstrate how to use Ubi Edge to rapidly author an edge-based opportunistic TUI. One day a user wants to author a smart light controller TUI by interacting with a frequently used cup. First, the user wants to turn on or off the smart light by touching the handle of the cup. So the user enters scan mode of the Ubi Edge and looks at the target cup for a brief moment. The user then enters author mode to define the edge of interest by simply sliding along the handle using the index finger. The selected edge segment is visualized with a virtual edge asset in AR. The user sets the edge type to discrete to let Ubi Edge treat the input as a button. Next, the user selects the on-off digital functions of the smart light from the menu and connects the selected edge segments with it via spatial programming. Now the user can turn on or off the light bulb using the handle of the cup. The user also wants to use the circular rim of the cup to continuously control the smart light's color. So the user re-enters the author mode and selects another segment using the index finger. Then the user sets the edge type for the rim as continuous, and Ubi Edge will treat the input interaction as a continuous value between 0 and 1. Next, the user connects the rim edge with the icon of color function and specifies the range of the smart light's color. Back in runtime use, the user can now adjust the light color by sliding left and right along the rim of the cup. We showcase 4 TUI applications created by Ubi Edge. Oftentimes, more than one edge exists on a physical object, so Ubi Edge enables users to repurpose a daily object into multifunctional controllers. Here, a user wants to control a smart fan using several edges on a book. Now the user can use the upper right edge to turn on the fan, use the lower right edge to let the fan oscillate, and change the fan speed by sliding on the bottom edge. Similarly, the user is able to use a scale to let the audio player start to play, jump to the next song, and change the volume. With the support of Ubi Edge, users are able to create tangible AR games that use everyday objects as controllers. Here, a user utilizes the game console's bridge to interact with a basketball shooting game. Ubi Edge can also improve users' task performance by enabling users to control tutorial-based TUIs. For example, when a user is cooking, he can control a cooking tutorial using the handle of the pan and the edge of the stove. We conducted a 2-session user study to evaluate the performance of our system with 14 users. In the first session, the users created and tested edges on 6 different objects to evaluate the performance of the touch detection and edge tracking systems. In the second session, we evaluated the design of the AR authoring interface by asking the users to author and experience 6 TUI applications. The high accuracy of detection results and positive feedback on the authoring workflow prove the usability of our system in customizing edge-based opportunistic TUIs. Thank you for watching. Please refer to our paper for more details of the system design and user study results.